Namaskar, this is Nayan and I welcome all of you to my new lecture series. Students, in my previous 7 lectures, I tackled a total of 35 problems from SLET 2024 Physical Science paper. Today also, I will continue this journey by solving another set of 5 problems. So, without further delay, let's get started. Problem number 36. This problem number 36 is also assertion region type problem. First, let me read the statements of assertion and region. Assertion: the atomic number of an element is changed due to radioactive decay. This statement is generally true. Students, during radioactive decay, such as alpha decay or beta decay, the atomic number of an element changes. In case of alpha decay, the atomic number decreases by 2, and in case of beta decay, the atomic number increases by 1 if it is beta minus decay, or decreases by 1 if it is beta plus decay. Next, region: the atomic number is changed due to radioactive decay. If gamma decay has taken place, the atomic number will remain unchanged. This statement is also true. Students, the atomic number changes due to radioactive decay in most cases. However, in case of gamma decay, the atomic number remains unchanged because gamma decay involves emission of energy rather than particles. So, it does not alter the number of protons inside the nucleus. So, after analyzing, we have seen that both assertion and region are true. So, therefore, the answer of question number 36 is option C. Both assertion and region are true. Now, let me write the equations for alpha decay, beta decay and gamma decay here. Alpha decay. Suppose X is the parent nucleus whose atomic number is Z and mass number is A, and Y is the daughter nucleus whose atomic number is Z minus 2 and mass number is A minus 4. Next one is alpha particle or helium nucleus. So, here we have seen that in case of alpha decay, the atomic number is decreased by 2 unit. Next, beta decay. We know that beta decay is of 2 types, beta minus decay and beta plus decay. So, first one is suppose beta minus decay. Again, we assume that X is the parent nucleus. The daughter nucleus becomes Z plus 1 A plus electron plus 1 electron antineutrino. So, here we have seen that during beta minus decay, the atomic number is increased by 1. Next one is beta plus decay. Again, X is the parent nucleus. The daughter nucleus becomes Y Z minus 1 A plus 1 positron plus electron neutrino. Next, let me define what is gamma decay. Students, after alpha decay or beta decay, the product nucleus or the daughter nucleus can lie in any one of the excited states. So, to achieve stability, this product nucleus or the daughter nucleus emit gamma photon, and this is known as the gamma decay or gamma radiation. In case of gamma decay or gamma radiation, the atomic number of the product nucleus remain unchanged. Now, let me write these points. So, suppose this is the case of alpha decay. X is the parent nucleus, we get a daughter nucleus which is in excited state. ठीक है, plus 1 alpha particle. So to achieve stability, this daughter nucleus always emit one gamma photon. Z minus 2, A minus 4 becomes Y, A minus 4, Z minus 2 plus 1 gamma photon. So we have seen that during gamma decay, the atomic number remains unchanged. So therefore, the correct answer of question number 36 is option C. Both assertion and reason are true. Next, let us move to question number 37. This question number 37 is assertion justification type question. Assertion: in interactions involving strong force, one must take care of strangeness of the particle. This statement is true. ठीक है? Of course, in interactions involving the strong force, we have to take care of strangeness of the particle because they can affect the outcome of an interaction. Justification: this is because strangeness is a conserved quantity in strong interaction. This statement is also true. The strangeness is indeed a conserved quantity in a strong interaction, meaning total strangeness before and after the interaction remains the same. ठीक है? So after analyzing, we have seen that both assertion and justification are true. So therefore, the correct answer of question number 37 is option B. Both assertion and justification are true. Now let us discuss question number 38. This question number 38 is also assertion reason type question. Assertion: if electric and magnetic fields be mutually perpendicular in one inertial frame, they do not remain perpendicular in another inertial frame. Students, this statement is false. ठीक है? Always remember, if electric and magnetic fields are mutually perpendicular in one inertial frame, they remain perpendicular in another inertial frame due to relativistic transformations of electric and magnetic fields which preserve orthogonality under Lorentz transformation. ठीक है? Reason: E dot B is not relativistic invariant. This statement is also false. Actually, the quantity E dot B is a Lorentz invariant quantity. This means the scalar product of electric and magnetic fields remains the same in all inertial frames. For example, if the scalar product of electric and magnetic fields is 0 in one inertial frame, then this product will also be 0 in all inertial frames. Now let me write this point. Suppose the scalar product of electric and magnetic fields is 0 in one inertial frame. Suppose that frame is S frame. Then the scalar product of electric and magnetic field will also be 0 in another inertial frame, suppose in S prime frame. So from this relation, we have seen that if electric and magnetic fields are mutually perpendicular in one inertial frame, then they remain perpendicular in another inertial frame. So after discussing, we have seen that both assertion and reason are false. So correct answer of question number 38 is option B. Both assertion and reason are false. ठीक है? Next, question number 39. This question number 39 is also assertion reason type question. First, let me read the assertion and reason statements. Assertion: for any scalar function lambda, we can add gradient lambda to vector potential A provided we simultaneously subtract del lambda by del t from scalar potential V such that electric and magnetic fields are not affected. Students, this statement is true. Now let me explain you how this is a true statement. First, let us check what are the important informations are given. So according to this question, lambda is the scalar potential, A is the vector potential, V is the scalar potential, E is the electric field and B is the magnetic field. Students, from electromagnetic theory we know that vector potential A, scalar potential V are related to electric and magnetic fields are as follows. Now let me write these expressions. So from electromagnetic theory, magnetic field can be written as the curl of vector potential A and electric field can be written as the negative gradient of scalar potential V minus del A by del T. ठीक है? Next, according to this question, if we add gradient lambda to vector potential A and if we subtract del lambda by del T from scalar potential V, then we should get the same electric and magnetic fields. Now let us write these statements in mathematical form. So according to this question, if we add gradient lambda to vector potential A and if we subtract del lambda by del T from scalar potential V, then we should get the same electric and magnetic fields. ठीक है? Same electric and magnetic fields. Now let us check whether this statement is true or not. Now let us calculate the value of magnetic field due to vector potential A prime. ठीक है? So B prime will be curl of A prime. We know that A prime is A plus gradient of lambda. So let us substitute this term here, A plus gradient of lambda. Next, let us simplify this term. So after simplifying, we will get B prime equal to curl of A plus curl of gradient of scalar function lambda. Again, from vector identity we know that curl of gradient of scalar function is always 0. So this term is always 0. So ultimately we will get B prime equal to curl of A. Again we know that curl of A is B vector or magnetic field. ठीक है? Next, let us find out the new electric field vector. E prime will be equal to minus gradient of V prime minus del A prime by del T. Next, let us substitute the values of V prime and A prime here. So minus gradient of V prime means V minus del lambda by del T minus del T of A plus gradient lambda. After simplification, we will get new electric field E prime is equal to minus gradient of V minus del A by del T, which is equal to old electric field E vector. So we have seen that if we add gradient of lambda to vector potential A and simultaneously if we subtract del lambda by del T from scalar potential V, then we will get the same electric and magnetic fields. So therefore this assertion is true. Next reason, divergence of curl of a vector is 0 and also curl of gradient of a scalar is 0. This statement is also true. Okay? So this is from the vector identity topic. So after analyzing, we have seen that both assertion and reason are true. So therefore, the answer of question number 39 is option B. Both assertion and reason are true. Finally, let us discuss question number 40. This question number 40 is assertion justification type question. Assertion: a 2-wire 100-meter long transmission line got cut at a distance of 60 meter from the sending end. The fault can be located by electronic technique at the input end. Students, this statement is true. Okay? The common electronic techniques that are used for detection of faults in a transmission line are time domain reflectometry and frequency domain reflectometry. Okay? Next, justification. The technique utilizes reflection of the propagating wave from the fault location and the input impedance measurement as a function of input AC signal frequency variation. This statement is also true. Okay? Always remember, this TDR or FDR technique utilizes the reflection of propagating wave from the fault location. So after analyzing, we have seen that both assertion and justification are true. So therefore, the answer of question number 40 is option B. Both assertion and justification are true. This is all about today's video, and I hope that you have learned a lot from this video.